Hello, dear students. Today we are going to study gases, and in special, we are going to see the different laws about gases. The gases has three main characteristics that we are going to see one by one. Well, here you have a balloon, and as you can see, the molecules in the balloon are trying to get all the volume of the balloon. Then we can say that the gas's molecules uniformly fills any container. Number two, you have two gases and you mix them and they completely mix one to another gas. And number three, they exerts pressure on its surroundings. What does it mean? That the pressure is all around. These three characteristics are very important in order to see the different laws that we're going to study today. Look at this. The, the gas measurements and the units. This is very important. Pressure. Well, the pressure is expressed in torr or atmosphere. The volume, V, is expressed in liters. The temperature, T, is expressed in Celsius degree or kelvins. Well, I put here kelvins in red because for some uh, um, calculations, we have to work in kelvins. If not, we don't get the right answer. I'm going to show you. Well, let's begin by the units of pressure. The units millimeters of mercury is often called torr. Then when I speak about torr, is the same as when I say millimeter of mercury. And the other one is atmosphere. That is a related unit of pressure. In the Pascal is the international unit for um, the unit for the international system. In general, we can say that pressure is equal to the force divided by the area. We can say that Newton divided by a square meter is 1 Pascal. And this is the unit that is used in the international system. The relationship between the different pressure units are one standard atmosphere is 101,325 Pascal. And one standard atmosphere is equal to 760 millimeter of mercury. In other words, 760 torr. Take into account that in order to do different calculations, we need to use these relations between units in order to do calculations. For example, you can make a conversion factor. Remember that in chemistry we use dimensional analysis, and in dimensional analysis we use what we call um, conversion factors, we use, for example, that 1 atmosphere is to 101,325 Pascal, or the opposite. We can say that 101,325 Pascal is to 1 atmosphere. And this is a conversion factor that we can use in these calculations. For example, the pressure of the air in a tire is measured to be 28 PS1. It means pounds per square inch. Represent this pressure in torr and in Pascal. What do we need to do? First, we want to convert from units of pounds per square inch. In other words, PSI means pounds per square inch to units of atmosphere, torr, and Pascal. What we know, what is given, 28 PSI. What information do we need? Well, the equivalence statements for units. For example, I know that 28 PSI multiplied by this conversion factor. I know that 1 PSI is this amount of atmosphere, and I use this as a conversion factor in such a way that I can cancel this with this, and the answer will be in the unit that I am looking for. Then I multiply this number by this number, and the calculator will give me a very long number. But the given number has two significant figures, and we have to report two significant figures. And the answer is that 28 PSI is equal to 1.9 atmosphere. This is a way that we can solve this problem. Here you can stop the video and you can see the way I use these conversion factors to change into torr or into Pascal. And as you can see, I use or I report only two significant figures in my answer. In this case, I use scientific notation in order to make the answer shorter. Here you have another question. The vapor pressure over a beaker of hot water is measured as this amount. That is what is given. This is given. What is the pressure in atmosphere? Then I use this conversion factor in such a way that I can cancel torr with torr. I multiply and divide, and I give this answer. Why only three significant figures? Because the given number, the information that is given, has only three significant figures. So my answer must have three significant figures. Well, the first law that we are going to study is the Boyle law. Let me go back. Boyle was a scientist that lived during these years. And he was one of the most intelligent men during the time he lived. So he was an English-Irish philosopher writer, but he was focused on chemistry, physics, and natural history. His work with pressurized air led to the development of one law that is very important. It's known as Boyle law. He described the relationship, sorry, between pressure and volume of the same gas. And he observed that the relationship between pressure and volume was constant. If you multiply this number by this number, you get this. Rounding, you can see that is constant. The relationship between the pressure and the volume when the gas when the number of mole of gas and the temperature were constant, then the relationship between pressure and volume was constant. Then we can say that the Boyle law is PB1 times P1. B1 is equal to P2 B2. Then, if I give you the original pressure of the gas and the volume, and I say that, for example, the gas volume is lower, then we can calculate this pressure. And as you can see, when the volume decreases, the pressure increases because they are inversely related. Exercise. A sample of helium gas occupies 12.4 liters at certain temperature and at this pressure. What volume will occupy, this is the question, that's what we are looking for, will occupy at this pressure? Then you use this formula. You have this pressure, you have this pressure, and you have this pressure. Then you have to find out the volume at the end. How you do this exercise? Well, you know, you can calculate the volume too using math operations, and the answer will be this one. As you are multiplying and dividing, and the three number has three significant figures, you report three significant figures. Remember that in multiplication and division, you report in your answer the number with the lowest number of significant figures in one of the factors. Here we have another law. This is the Charles law. He observed that when the volume increases, the temperature of the gas increases. So they are directly proportional. And he got this structure. Well, here is very important that you work with the temperature in Kelvin. If you use Celsius, the answer will be incorrect. Here in the Charles law, you have to convert Celsius to Kelvin using this equation. Well, look at this. Here we have a problem. The balloon contains 1.30 liters of air and at this temperature. And it's placed into beaker containing liquid nitrogen at this temperature? Oh, the temperature decreases. What will be the volume of a sample of air become? Well, the pressure is constant in this case. Then you use this formula. You have this volume, and you convert the temperature into Kelvin using this formula. You don't know this volume, and you convert the temperature using this formula, and then you can calculate the volume at the end. This is very simple, as you can see. This is the Charles law that says that the volume and the temperature of a gas are directly proportional. If one decreases, the other also decreases. Remember that what is a mole? Well, a mole is a reference point for most calculations and equations in chemistry. One mole is the amount of particles of any kind of substance. One mole always, it doesn't depend if it is gold, if it is water molecules, anything, the number of particles always in one mole of any substance is 6.02 times 10 to the 23rd particles. The Avogadro's law established that the relationship between the amount of substance and volume is directly proportional, and he uses this formula. If you know the number of moles and the volume of one state of the gas, you can find out the volume or the number of moles in other state if you know one of them. For example, 2.54 moles of argon gas occupies a volume of 89.0 liters. What will the volume of 2.810 mole? Well, you can calculate volume 2 using this formula, and here is the answer. Remember, 3 significant figures because the factors here, everyone has 3 significant figures. If one of them has only 2 significant figures, then your answer must have 2 significant figures. The ideal gas equation is a combination of the 3 laws and establish that pressure times volume is equal to the number of moles times the constant of the gas, that is R, times the temperature. The constant of gas can have this value. If we are going to work in liters atmosphere, we use this. If we are going to use in Pascal, well, there is another constant. If you're going to use torr, you're going to have another number here. Let's do this exercise. An automobile tire at 23 Celsius, well, the first thing that you're going to use is to convert 23 into Kelvin using this formula. Look, temperature. You have the constant of a gas here, and the volume is 25 liters, and the pressure is 3.18 atmosphere. Then you multiply and divide, and you get that your answer is 3.27 moles. Here we have another exercise. What is the pressure uh, of a gas with this volume that contains this mass, and it is helium, and this is the temperature. Well, in this case, you don't have mole. What you have? You have mass, and you know that is helium. Then you can calculate according with the atomic mass in the periodic table. You can divide the mass by the atomic mass in the periodic table, and you get mole. In this case, here you have the mass, then you multiply by this, and you get mole. And of course, you have the conversion of kilograms into grams using this conversion. Then here you have moles. All these operations correspond to mole. Then you have here the R constant, and here you have the temperature that is converted into Kelvin using this formula, and then you divide everything by the volume in liter. Your answer is that the pressure of this amount of gas is 114 atmosphere. Here we have another exercise. You can stop the video and you can see here is your answer. Remember, here you have, in this case, you have to find out the temperature in Celsius. Then here you have that the relationship between the partial and total pressure in a gas mixture. Well, the total pressure of a mixture of gases is the sum of the partial pressure of every gas. The pressure of the gas is affected by the number of moles of particle present. Of course, if you have more particles, the pressure will be higher. And two crucial things to be learned from Dalton law. The volume of the individual particle must not be very important. The forces among the particles must not be very important. So let's collect a gas into water. Well, in this case, we are using potassium chlorate. When we heat potassium chlorate, this potassium is decomposed into potassium chloride that remains here is an ionic compound, and the melting point is very high, so will remain solid here, but produces the decomposition of this gas because of the heat produces oxygen, and this oxygen goes into here and is displays the water in this bottle. At the end, we can measure the volume of this gas. Knowing the volume of this gas and knowing the amount of potassium chloride and knowing the 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 mass of oxygen that is produced because of this decomposition, you can calculate, for example, the R constant. This is a lab that we usually do at this level of college, calculate the experimental R constant. When we collect a gas over water, it's very important to measure the volume, the temperature of the gas, and according with this, we can calculate the pressure of water as a function of the temperature. Let's see this exercise. Consider the following apparatus containing helium. Both sides has the same temperature. Then the temperature is constant. What you have here, oh, the pressure here is this. And when you open the you know this volume and you know this volume. When you open here, certain amount of gas will goes from the biggest volume to the small volume until you get an equilibrium. At this point, what is the pressure of the helium gas? Well, how we can calculate this? We have the pressure at the beginning and you have the temperature and you have the volumes, then you can calculate what will be the pressure here and what will be the pressure here. Of course, remember that the particles here are closer than here, then exert a higher pressure because the volume is smaller. Remember that pressure and volume are directly proportional. If the volume decreases, the pressure increases. That's why here the volume is higher than here. Here we have another exercise. You can stop the video. You have already the answers. Then what you need is to stop the video and answer this question. You have more exercises. Here you have the scientific method that we studied before. We have the kinetic molecular theory. Let's stop into here. So far, we consider what happens, but not why. In science, what always comes before why. Gases consist of tiny particles that can be atoms or molecules. So remember that sometimes the atoms, in order to be stable, make molecules. The particles are so small compared with the distances between them. What does it have? What does it mean that, for example, if this is a molecule, the other molecule is here, and the distance between two molecules is always larger than the size of the particles, then we can assume that the size of the particle is almost zero. The particles are in constant and random motion. One is moving here, the other is moving this way, the other is this way. They are in random movement with the walls of the container. They are colliding all the time with the walls of the container. These collisions with the wall will cause what we know a pressure. It's the pressure that the gas is exerting over the walls of the vessel. The particles are assumed not to attract or to repel one to another. The average of kinetic energy, remember that kinetic energy is the energy that is related to the particles in movement of the gas, is directly proportional to the Kelvin temperature of the gas. So, what are the implications of the kinetic molecular theory? Meaning of temperature. Kelvin temperature of a gas is directly proportional to the average kinetic energy of the gas particles. The relationship between pressure and temperature. The gas pressure increases as the temperature increases. And because the gas particles move faster and undergo collisions more often. The relationship between volume and temperature. Well, the volume of a gas increases with the temperature because the gas particle speed up. Well. You are holding two balloons of the same volume. Volume 1 and volume 2 are the same, but one contains helium and the other contains hydrogen. Complete each of the following statements with different or the same, and be prepared to justify your answer. The pressures of the gas in the balloons are, well, what do you think? Are the same. Because remember, the we said that the two balloon has the same volume. Then volume 1 is equal to volume 2. So pressure times volume is constant. If the pressures, if the volumes are the same, if the volumes are the same, the pressure must be also the same in order to be equal. Remember that we studied this. Let's see. Complete the following statement. The temperature of the gas in the two balloons are the same. Remember that if the volume and the temperature is a constant, then the volume of helium and the volume of hydrogen are the same, then the temperature must be the same. Let's continue. The number of moles, well, remember, number of moles and volume. If the volume is the same, the number of moles must be the same. What about the densities? Well. Of course, the volume is the same, but the number of moles is not the same because they have different atomic number. Then mass, the mass of helium and the mass of hydrogen will be different because remember that mass is equal to number of moles times density. Then, if the mass is different, then the number of mole is different, then the density is different. Well, here you have the relationship, the, the expression, the graph of the change of the pressure and the volume. As you can see, they are inversely proportional. When the pressure is high, the volume is low. And when the pressure is low, the volume is high. The volume and the temperature that are directly proportional. When one increases, the other increases. And here we have, which of the following best represents the mass ratio of neon argon? Well, the answer is 1:1. I'm not going to give you the explanation. You have to figure out. Here you have another concept check. You can stop the video, answer this. Here is a continuation, and here you have the answer. Try to stop the video, and you will see what is the answer. Well, here we have seen the characteristic of the gas. We have studied the different laws of the gas, and we studied in a simple way the kinetic theory about gases. That's it. I hope you understand and can answer the exercises for this chapter.